Okay, so in this video, we are talking about 3.2, which is all about applications of radian measure. Okay, so again, what we're going to do is we're going to use the radian measure to find the length of an arc of a circle. Okay, so here's our kind of definition of what an arc length is. It is saying that the length of S of the arc, so our S is this guy right here, is intercepted on a circle by the radius r, so again this is our radius right here, by the central measure of your theta radians, okay, which again is right there, is given by the product of the radius and the radian measure of our angle. So basically it's this lovely equation. So S is equal to R times theta. So again, S is our arc length. And there is a reason why we are not using the letter A for arc length, okay? Because usually A stands for area, okay? Your R is your radius, and your theta is your angle, and we're always talking about it in terms of radians, okay? So in the next couple examples, you guys are going to need your calculator. So if you do not have a calculator, please make sure that you pause the video and get one. Okay, so let's take a look at our first example. Okay, so our first two examples say this. So a circle has a radius of, oh, I forgot to put in what the radius is. The radius is of 18.2 centimeters. What we're going to ask is to find the arc length intercepted by the central angle having each of the following measures. So the first one will be 3 pi over 8. So again, we don't see that little degree symbol, so we know it's not degrees, so we know that this is in radians. And then 144 is in your degrees. Okay. So again, if you want to try pausing the video and attempting these problems on your own, feel free. Okay. So, but essentially all we're doing is we're plugging in what we know and we're solving for the unknown variable. Okay, so I am, again, using this equation, S is equal to R times our theta. Okay, I am given the radius as 18.2. So I know that I'm going to type in 18.2 right here for centimeters. And then my theta is in my radians. So remember, our equation is always in radians, so I don't have to do anything. So I just get 3 pi over 8. And this will equal my arc length. So again, we want to pull up our trusty calculator, turn it on, and all we're going to do is we're going to type in exactly what we see. So we're going to say 18.2. I'm going to multiply that by 3 pi. So pi is right here. And then I'm going to divide that by 8, close my parentheses, and press enter. So I get about 21.44 as my answer. I'll round it to just 2 decimals. So we'll say 21.44. Now, we're talking about length. So because my R was already in centimeters, that means that my arc length is also in centimeters. So this is my lovely answer. Okay. So 144. Okay, so let's try this. Now, I'm going to do a little visual on this one that I didn't do on the first one. So essentially 144. Right, so here's my lovely circle. Okay, and again, my radius is of the 18.2. I have a length of 144, so I know that that's in my second quadrant. So it'd be somewhere right about here. So again, this is 144. So essentially what I'm asking you to find is I'm asking you to find this length from here to here, right? This is my S, essentially. Now, we have an issue on this problem. Notice my issue is I said that this was 144 degrees, but we said your theta is always in radians. So what do we have to do? We have to convert. So the first thing I'm going to do is take away this pop-up ad. we go. So the first thing I'm going to do is I'm going to convert. So I'm going to say 144 times pi over 180. So this will give me radians. Now I'm going to be plugging it into a calculator to begin with, so I don't necessarily need to simplify my fraction. Okay, so this is now my new radians. So I'm just going to take my 18.2. I'm going to multiply it by 144 pi all over 180, and I'm going to plug it in. So let me move my calculator so we can kind of see what's happening. Oops. Up. So 18.2. Where did my, oops. Sorry, I lost my cursor for a second. And then 144 pi, and again divided by 180. Close that off. Press enter. So we have about 45.74, so we'll keep it as that. So our arc length is about 45.74, and again, this would be your centimeters. So again, this is all this is saying is what is this length from here to here. Okay, so plug it in, trying to figure out what's happening. All right, so finding the S, pretty straightforward. What happens if we want to figure out other letters of this equation? So this time I want to find the radius. So I kind of drew a picture of what we have. So again, S is equal to R times R theta. So this time I'm given my S. So my S is 3 pi. I'm also given my arc length, or sorry, not my arc length, my theta, which is this guy. And again, I don't know my R value. So I'm going to go ahead and I'm going to plug in what I do know. So I'm going to say 3 pi is equal to R times pi over 2. Now this one I could use a calculator for, but I don't necessarily need to use a calculator for this one. I can just multiply by the reciprocal, and that should be plenty enough for me. The pi's will cancel away, 2 times 3, and that will leave me with 6 is equal to my radius. Now I didn't mention what my arc length was in, so we would just say, you know, the radius is 6 units, right? If we want to be specific in terms of our measurement. Okay, so again, we can find our lovely radius. Let's figure out what our angle is. So let's do an example with our angle. Okay, so again, I have my equation. So S is equal to R times my theta. This time I know my arc length, so I know that that goes there. I also know, let me change my color, that my radius is 4. So the only thing I don't know this time is my theta. So again, I'm going to plug in. So S is equal to 6, R is equal to 4, theta stays as theta. Again, this one's pretty straightforward. I don't need a calculator for it. So I can just easily divide both sides by 4. And when you can, you want to try to simplify your fraction as much as possible. So 6 over 4 would just simplify down to 3 over 2. And again, this is in radians. You don't need to include that. We know that it is in radians. I can ask you for it in degrees, and then we can go ahead and we can actually change our values. Okay. So let's try 2 more, and I'm going to let you guys pause the video, try these out, see what happens with these 2 more examples. So find the arc length with the given information. Again, use a calculator. All right. So again, if you're coming out from the paused video, so again, your R and your theta, again, this is just practice plugging in what we know. So 0.892, we're going to multiply that by 11 pi over 10. Move my calculator one more time. So I'm going to say that it's 0.892 parentheses 11 pi divided by 10. All right, so we got 3.08. So again, 3.08. Let's keep the centimeters, right, as we are solving this problem. Okay, hopefully for this one, we remembered to change our degree, and we're going to multiply it by 100, pi over 180. So 71.9 times, this will be 135 pi over 180, right, is equal to my S. So again, we're going to plug in what we know. So 71.9 times 135. 135 is going to be something that you'll eventually have memorized. But for right now, we just plug in as we go. So this gives us a grand total of 169.41. So 169.41. Again, I include centimeters for this problem. So let's do one last example that's kind of putting things all together using our knowledge of, S is equal to R times R theta. So here's our word problem. So the rotation of a smaller wheel causes the larger wheel to rotate. Through how many degrees would the larger wheel rotate? It's supposed to say if the smaller one rotates through 60 degrees. The smaller wheel has a radius of 5.23 feet, and the larger wheel has a radius of 8.16 feet. Okay, so let me see if I can draw some lovely pictures. So here's one wheel, and I'm going to make this shape. There we go. And then I'm going to draw another wheel, a little bit larger, and shape fill. All right, so again, think about it this way. Try to get them as close as possible together. Okay, so here's my larger wheel. So let's pretend that this is the center. So this is 8.16 feet, and this more looks like an oval, but for our sake, this will also be a circle, so 5.23 feet. Okay, so what I'm trying to think about is I'm trying to move the wheel, the smaller wheel, 60 degrees, right? So let's pretend that the highlighted motion is my 60 degrees, okay? That means, right, that 60 degrees, that wheel is going to turn my other wheel 60 degrees. Or sorry, it's also going to turn it the same arc length. Okay, but it's not going to turn it just 60 degrees. We got to figure out what degree it's going to turn. It's going to take this larger wheel a lot more to turn than that smaller wheel. Okay, so again, I know that it's 60 degrees with the smaller wheel, so I need to set up an equation. So I'm going to do this in twofold. So I'm going to say the smaller wheel. And again, if you want to pause the video and try this one out on your own, feel free. So again, I know S is equal to R times R theta. So I want to figure out what this arc length is. So our radius is 5.23, and my radians is going to be 60 pi over 180. So I'm going to plug that into my calculator. Oop, my calculator turned off. 5.23, oops, 0.23 is 60, and then pi divided by 180. So my arc length is going to be about 5.476, so I'm going to round to about 5.48. So 5.48, and again, feet. So that means that this length right here is this length that's highlighted yellow, okay? Which also means that the blue length is also 5.48. The larger wheel will also move 5.48 feet. So I want to figure out what that is in degrees. So let's go ahead and continue. So again, I'm going to do my larger wheel. Okay, so now I know that this is 5.48. My radius is 8.16. I don't know what my theta is. So I'm going to go ahead and I'm going to divide these together. And let me move this over. Divide by 8.16. So I'm going to get about 0.6715. So I'll just round to 0.67. So my theta is about 0.67. Now, this is not in degrees, sorry. This is in radians. Now, since I originally gave it to you in degrees, we would probably want the answer also in degrees. So all I have to do is multiply 0.67 by pi, oops, other way around, by 180 over pi. So if I do 0.67 times 180 divided by my pi, I'm going to get my answer. And it gives you roughly about 38.38. I'm going to round it to about 38.4 degrees. So to answer the question, 38.4 degrees. This is what the larger wheel rotates. And that makes sense. It is a smaller degree than the other wheel. So we found arc length, we found radius, we found our theta, which is in radians, or we can change it to degrees. So what else could we do with arc length, right? We can also find the area of a sector. So area of a sector, instead of finding this length right here, what we're finding is this piece right here, right? So, so our area of a sector is, and again, this is why we didn't use A, is found by using this formula. A is equal to 1/2 r squared theta, where your A is your area, your r is still your radius, and your theta, I've already written, is in radians. So again, it's this shaded area. So again, a lot of these things you are just going to kind of plug in and kind of see what's happening. Okay, so let's test out a couple of our examples. So here's our first one. We want to find the area of the sector, the given information. So our first one is our arc length is 4 pi and our radius is 8. Okay, so so again, what do I know? I know A is equal to 1/2 r squared theta. So on this problem, so far what I know is I know that it's going to be 1/2 times 8 squared and then the theta. So problem, I don't know what my theta is. Okay, so I actually have to rely on the other formula that we just used. S is equal to r times your theta. So what do I know about that one? I know that 4 pi is equal to 8 times our theta. So that means that if I divide both sides by 8, I will get a pi over 2 is equal to theta. Well, that's great. So now I can replace these guys with each other. So this will become the area is 1/2 times, and I'm just going to make that 64 pi over 2. Now I can leave this in terms of pi if I wanted to, right? So if I multiply 64 by the 1/2 and by the pi over 2, I will be left with 16 pi, and this will become feet squared, right? Or what I can do is I can again say 0.5 times 64, and then again times pi over 2, and that will give me about 50.2, and I'll round it to 50.27. So 50.27, again, feet squared. Either one is perfectly fine for the area. Okay, so again, why don't you pause the video, try the second one out on your own, see if you guys can kind of figure out which formulas to potentially use. Okay. Okay, so again, what do I know? I know that I don't know what my A is. So I have 1/2 times my radius of 18.3 squared. And again, theta's in 125 degrees. I need that to be in radians. So I'm just going to multiply that by pi over 180. So again, this will give me 125 pi over 180. I only needed one equation. That was lovely. So again, I'm going to go ahead and multiply 0.5, and because I don't know what 18.3 is squared, so I'm going to leave that there, and then I'll multiply that by 125, 125 pi over 180. So this should give us 365.3, and I'll round it to 3.1. So 365.31. Again, I said it was meters, so because it's area, I should say meters squared. Okay, so again, one made us use two formulas, the other one we kind of just plugged in as we go, right? So what happens if I wanted you to find, again, the radius? So let's try a different problem. So this time I gave you the theta, I gave you the A. So again, A is equal to 1/2 r squared times your theta. So we're finding our radius. So let's plug in what we know. So 64 inches squared, so 64, 1/2, I don't know, r squared, and then times pi over 6. Okay, I can kind of do this in a couple steps. I'm going to multiply both sides by 2. So I'm going to get what? 128 is equal to r squared pi over 6. I can again multiply both sides by 6 pi, or 6 over pi, I should say. I don't know what that number is off the top of my head. So 6 times 128 gives you 768. So this will be 768 over pi is equal to r squared. Again, we're going to eventually have to use a calculator. R for your radius is always positive, so we don't have to worry about writing a negative number. So let's go ahead and plug in what we know. So I'm going to take the square root first. So square root 768. Divide that by my lovely pi. Boom. I get about 15.63 as my radius. So 15.63. I start off with inches squared, so that means my radius is just inches. Okay. So final problem. Let's kind of do a little word problem here. And so let's go ahead and look at this. So the Ford Model A, built from 1928 to 1932, had a single windshield wiper on the driver's side. Oops, that's supposed to say total. The total arm and blade was 10 inches long and rotated back and forth through an angle of 95. Oh, I forgot the degree symbol. So 95 degrees. If the windshield blade was only 7 inches long, what was the area of the region it would clean? Okay, so let's draw a lovely picture. So so let's pretend that this is kind of like the windshield wiper. So it comes up here, So we have this lovely sector. Okay, and this piece right here is 95. Okay, now I'm not a very good drawer when it comes to my windshield blade. So here is my best windshield blade, is that it probably looked something like this. And then, boop, boop, boop. So there's my lovely windshield blade. And then we can color this in. Okay, which means that the windshield blade kind of pretty much covered this area. So we want to know the red shaded region. Okay. So what do I know about this is I know that this guy is 7 inches long from here to here. And I know that this whole windshield is 10 inches long, right? From here to here. Okay. So, so we want to figure out kind of what we have to do. Okay. So again, if you want to pause the video and try this out on your own, feel free. Okay. But we are going to use this formula, 1/2 r squared in theta. Okay. So the first thing that I want to do is I want to figure out what the whole windshield would cover. So the whole 10. So I'm going to go ahead and I'm going to say the whole windshield. Okay, so I'm going to say my area is 1/2 times 10 squared. And again, it's in degrees, so I need to multiply the 95 by pi over 180. So 95 pi over 180. Okay, so go ahead and I'll plug this in. So 1/2 times 100, so that'll end up giving me 50. And then I'm going to multiply by that 95, again, pi divided by 180. So this gives me roughly, what, 82.903. Okay, cool. So the area is 82 and I'm going to use 903 because I don't want to use 90. And then this will be inches squared. So that's my entire region, okay? But again, I only want 7. Now you might be asking yourself, well, why can't we just use 7? Well, we have this kind of little divot right here, okay? And it wouldn't cover the whole area. It wouldn't be a good, clean sector, okay? Because we're missing this kind of part. So essentially what we want to do is we want to figure out what is highlighted in blue and kind of take that away, right? So if I know that the whole windshield blade is 7 inches, that means that there's 3 inches unaccounted for, right? So the next thing I'm going to do is I'm going to find the unaccounted 3 inches. Okay, and I'm going to find that area. So I'm going to do the same exact thing. So area is 1/2, again, 3 squared. And then this, again, will be 95 pi over 180. So 3 squared is 9. Half of 9 is 4.5. So if I do 4.5, again, times 95 pi over 180. I'm going to get that little unincorporated area as about 7.46. So this is, again, 7.46. And again, this will be inches squared. So basically what I want to do is I want to figure out what the 7 inches is. So what you are going to do is you are going to take your whole windshield and you're going to minus the 3 inches from it. So we're going to take the 82.903 and I'm going to subtract 7.46, and that should be the remaining area sector. So 82.903 minus 7.46, and I'm going to get a grand total of 75.443. So this is the whole area. So 75.443, again, inches squared. That is what the area that the windshield wiper actually cleaned. All right, so again, fun little fact, this is true, what windshield wipers kind of look like. Okay, if you have any questions, stop by for tutoring and I can help you then.